Hello. In this tutorial, we will talk about how to persistently save the position, rotation, and material of the game object. For this purpose, we will write a script and attach it to the game object that we want to save. Now, let's start with creating a game object in the scene. We right-click here, and then let's create cube. Let's also now adjust its size. And also now its position. We can see here in the game object section. Now let's create our script and attach to this cube or game object. We can go to the scripts folder and we can right click here and create C# script, and we can create now its name. Rename, let's say save load transform and material. Now let's I already wrote a script, and let's copy and paste the script here. Now this script will be responsible save and load the texture, the position, and the rotation of the game object. But to do this, we need a menu in the right section of the inspector section of the Unity. So for that, we need to create also a script to create load and save buttons in the inspector section. Now we will create a script and put it to the editor folder here. Now let's create that responsible script for the inspector. For that, we again create C# script here, and now we will give a name for it. Rename, let's say save load material, save load transform and material editor. And if we double click the code, we open it, and let's paste the code here. We now created two script. Now we have to attach the first script to this cube game object. For this purpose, let's choose this game object and let's drag and drop this script here. Now we see as we see the UI of the inspector section has changed. Now we can see the two buttons here. Now we will investigate the code and we will see how it works. If we click the code that we attach to the game object, now we can see the code here. Now let's see how it works. Firstly, our aim to save position, rotation, and material of this game object. So we create a class here, and yeah, we and create the variables inside of it, and then create a function which is responsible for to change the the values of these variables. So if you go here, to save the data, we create a function here. Then inside of this function, with the renderer component, and using it, we get the name of the material. Then by initiating our object, our class that we specified here, we use the position, rotation, and the material name here. Then we store this information in the JSON file using a JSON utility component, and we store this data in the persistent path. Now if you run the game, we will see also where is this path. And another function is here to load this saved data and use it in the next run of the game. So we read this JSON file again with the same name in the persistent path. So we assign this the position, rotation, and material name to the variables here. Then if you want to change for changing the material, firstly it searched the all materials in the scene, and then if the name of the material match that we assigned here, then it change the material. Otherwise it turns the default material like it had before. So yeah, this code works like this. Now let's run the code, run the project. Before run the game, let's investigate also our editor script. Let's double click the editor script here. Here, first two line of code, this declares a custom editor for the save, load, transform, and material class. The custom editor here attribute tells Unity that this editor script should be used to customize the inspector for the save, load, transform and material component. And this method overrides on inspector GUI, which is responsible for drawing the GUI elements in the inspector. And this call here draws the default inspector elements, so all the standard fields of the save, load, transform, and material component are still shown. And this line here gets a reference to the script being inspected. With the target, it is save, load, transform, and material script. And this if statements here will create save button and load button in the GUI layout. Now if we hit the run button here, let's run the project. So now let's take this scene to here and game here. Now let's in the scene section, let's change the position of this game object and also the rotation. Let's make it this, or even put different place like here. Okay, so now let's click the save, transform, and material button in the inspector. And now we stop the game. Now if you rerun the game again, if we now hit the load, transform, and material button here, it will like we saved the transform and we saved the game object's position, rotation, and previously, and we will load it again. Now if we press this one, as we see, previously we selected this location and this position, and we changed the rotation like this. Now we reloaded the previous position and rotation of the game object. Now let's change the material also this time. Run again. Let's change its position this time here, up, and change the rotation, and this time let's change its material here in the element at the mesh material section here, and we choose different material in the element 0 section. Let's this time take this one and click save, transform and material again, and we can stop the project. Now rerun again. If we hit load, transform, and material again, now we will see the object, game object here with the different material. Let's hit it. Yes, we see the game object with the different material here. If you want to investigate the JSON file and where it is, so in the code, let's go here. We wrote the debug log line here, and we should see the where it is this path. That we can see it in the console. Let's click it, and it is in it is in application data / local low. Usually this path is hidden, so you firstly make it showable, then you see it. I want to show you how it stores this position, rotation, and material information in the JSON file. Yes, this is the JSON file we created to store this data. As we see, the position is here with the 3 coordinates and rotation again, and its material name we changed like BG bump here, and we store it in this path as a JSON file. Then by using again this JSON file, we reload the position, rotation, and the material to the game object. Now let's extend our approach to the traversal hierarchy. That means if we have child and parent mechanism of the game object, we should be able to also save this position, rotation, and material change of this child object. For this purpose, I updated the code and gave another name to it, save load hierarchy. Let's double click and let's investigate the code a little bit. Basically the code is almost same with the previous code I showed you. Technically I created 2 different function here, which is responsible for saving the child of the game object recursively here. It search for the childs, and for each child recursively do the same process. The process is here just saving the position, rotation, and material name, and the load function. This process reversely and recursively happens again. We so it loads the position, rotation, and the material name, and recursively search for the child, and for each child it's making the same process again. The other components and the class of the code is completely the same. I only changed the names of the functions here, and it will write this data JSON file with hierarchy name. Now let's firstly remove our previous component. Remove this component, and we will add this save load hierarchy script here. Drag and drop again. And I updated the name of the buttons in inspector section. So let's update the editor code again. Let's double click this and open the editor code again. I just changed the GUI layout button names here. Now it's save hierarchy and load hierarchy. The other sections of the code is completely the same. As we see here, the name of the buttons has changed. Now to create a child-parent mechanism in the scene, let's create a cube, a small cube here. Then let's front side, maybe here a little bit. Section also. Then let's make this cube as a child of this parent cube. We just drag and drop here. Now we created the parent and child hierarchy here. Now let's run the project and see how this parent and child game object works with this save and load mechanism. Let's hit the run button. Now let's change this game object's position. As you see, since it has a parent and child hierarchy here, so it moves together. And let's change also its rotation. And now let's change the material of parent game object. And now the child. Let's choose, for example, this one. Let's now save it and then stop the game. Now run again. Load. As we see now, we see the previous position of the two game objects like we changed before. And of course now we can see for example, the JSON file. Since we have two game objects, now we can see the two different data for each of them: position, rotation, and name of the material that we changed, and it stores here. And then afterwards, if we click load button here, it retrieve the information from this JSON file. And We can also search different alternatives to save and load the specific data we want. For example, we can use asset store to download and import an asset for this purpose. There's one suitable asset for this task called extendable save system. Let's search and download it. We can go asset store and search online. We click. Let's write the name of the asset here. Extendable save system. This one. It is free to use. And like we did in our previous video tutorial, we click here to add to our assets. And we choose our account, then enter necessary information. Then if we click open in Unity, yes, then if you download this first time, you will see this button as a download here. And after that, if you click import, it will import here. I have already did this steps, so I have already imported this assets to my project. Now we can go back to our project and scene. Let's open the sample scene from this asset. Example scene. Let's take the game section here. Let's start from the beginning. I will delete this cube. If you want to save and store the data like position and rotation, we have to put each game object under save objects here. After we make manipulations during the live mode, the position and the rotation of those objects will be saved if we click the save button in the UI. These buttons as a UI element UI elements on the game window. Then if we stop the live mode and restart again, we press the load button here in the interface, the respective data will be loaded. Now let's start to create a cube, for example, and create second one. And put under save game on, and this one is a here. And also maybe we can put this as a child under this parent cube like this. Now let's hit the start button. And now let's change the game objects position and rotation. Let's change the rotation also. Now let's hit the save button, then stop the game, then let's start again. Now if we hit load button, we will see the previous position of these two game object that we saved. Yeah, like this one. Now we can stop. Yes, if you want to use these assets, we should put our game objects under the game object we want to save the data under these save objects. Then it doesn't matter it is a hierarchy, parent and child hierarchy or not. And this asset has a drawback, so I tested with changing the materials of this game object, but it didn't work. So it works only the spatial information of the each game object, like rotation and position. But like we see in our previous tutorial, we can extend this code by including the code we investigate previously, and we can basically extend this this asset. Next section of this tutorial, we will implement a script that allows a user to rotate the camera around a spherical object in Unity using mouse drag motions. It will capture the mouse position when the button is pressed, will compute the necessary rotation based on the drag motion, and will apply the rotation to the camera. Now let's firstly attach our script to the game object that we want to have camera rotation ability as a reference point. Then run the game and see how it works. Now let's create our script. Here we can create C# script. Let's give a name, spherical rotation. Let's open it. I have already created the script, then I will paste here. Now it's ready to attach to the game object. For example, let's attach to this this orange color game object. Let's choose object and simply drag and drop. Now we attached our script to the game object. Now we can run the game. Now if we click the game object that we attached the script, we will see the camera rotation. To see it better, now let's choose the camera on the scene section, then let's rotate it. By the way, the ink painter, this object also has another script that belongs to ink painter asset pack, so that's why if I click the surface of this game object, it's painted, but doesn't matter for us. We will see how this camera spherical rotation of the camera works. So now as we see at the downside, the camera here, and we can see how it rotates, and actually the mechanism is like Google Earth. If you use that application before, the mechanism is almost same. If I click the center of the game object, the rotational speed is a little bit lower, but if I click to the edges, it's a little bit the speed is a little bit higher. Since we attach this this script to this game object, it only works with this game object. The other game object will not work. So if we click this one, for example, it doesn't rotate the camera. It only works with the game object we attach the script. Now, as the next phase, we will investigate investigate the script, and we will understand how it works. We can stop the game by clicking here, then double click the script and you can see it. The code is not long. Let's line by line explain the code. So the class inherits from mono behavior, so that means we can attach this script to game object, and here the constant integer, sphere radius constant integer representing the radius of the sphere, and here mouse start position and current position, these fields to store the starting and current mouse position in the world space. And there's start method here. The method initialize the camera to look at the object. The commented out code indicates how the position and the orient to the camera, but it's now currently disabled, we don't use it. The update method here, if it checks if the left mouse button is pressed down, then, and if so, gets the mouse hit position on the sphere here. If it is not null, it calls the handle drag to process the dragging, and it checks if the left mouse button is released, then it runs a handle drop method to reset the mouse position. Here handle drag updates the current mouse position and calls rotate camera to rotate the camera based on the drag motion. Here handle drop resets the mouse position variables to null when the drag ends. In the rotate camera performs the actual rotation. It normalizes the start and end position to the sphere's radius, calculates a perpendicular vector here to rotate the around using vector 3 dot cross method here, computes the angle of rotation using vector 3 signed angle component, and rotates the camera around the sphere centered by this angle and vector, and get mouse hit method here. It makes ray castings. It casts a ray from the camera through the mouse position, and if the ray hits the sphere, it returns the hit point. If not, it returns null. This was the script, and we explained how it works. Next section of this tutorial, we will use a plugin called Cinemachine to have different camera rotation abilities. This plugin has many behaviors and features, but we will firstly implement a free camera look property of this plugin. But before implement this, let's firstly see how can we install this plugin. To install this plugin, we should go to Package Manager. Then, we should go to Unity Registry. We can see many packages in this list. We have to find Cinemachine. It is here. I have already installed it. That's why it's this green thick sign here. So, but for example, imagine if I hadn't installed this, like it should be like this, the install button here. If we click this, install button, it will install this plugin to our project. Now let's implement free camera look property. For this, in game object section, we should see Cinemachine here, then free look camera we choose. We will see here it comes with this this sign in the scene section. It has many properties as we see in inspector, but two main properties actually follow and look at properties here. Then, for example, we can start. I will select, for example, this one. sphere 1 as a follow. Sphere 1, I can choose this game object and look at, for example, if I want to look at this game object during the move, because this game object has a rigid body, so it will fall down on this plane and then to the void. And let's then choose look at as a canvas sphere. This one. If you now run the game, we see now we have free camera look, but we can increase its degree. For example, as you see, we always look at this game object, the canvas sphere game object, but it's also following this falling down sphere. Now if we have a look to the properties of this free look object, this section, top rig, middle rig and bottom rig, will change the position of the free look camera. And if you want to look at around fastly, we should change the value of, for example, the speeds, let's say 1000, and maybe top is better to see properly. Let's rerun again. As you see the camera, we can see the x-axis more fastly. Yeah, we can just play with these properties and find better option for us. Let's stop. Now as a next run, I will change, follow and look at property with different game object in the scene. For example, now let's choose parent and child game object here. For example, we can look at the child object, which is cube 1. Then let's follow the parent, which is cube. I also for the parent one, I implemented a very simple script here. Maybe we can have a look. This parent and child objects will move with, if I press WSAD configuration, will move basically forward, left and right and back. So now we will see how this free camera property will work. Let's start again. As you see, these objects are moving, and I can have a look to to do around some level. Yeah, we can change the properties by just basically playing with this the inspector, the right side. We can change the sensitivity of the mouse with this X and Y axis values, and maybe I haven't used this section, but yeah, for our preferences we can choose whatever we want here. In this part, we will use track and dolly feature of Cinemachine, which gives us bespoke way to track targets in our scenes by setting paths for our virtual cameras move between. If you want to include this feature to our project, we should go for game object section here, then Cinemachine, and we should choose dolly camera with track. And if we select this, then it will comes with two different game object here, dolly track 1 and CM cam 1. We should adjust the features of this two game object to have a desired track route of an object. Here this two feature is also same like we saw previously in free look camera. So as a first example, we will follow again this this sphere object which has a rigid body, so it will fall down from the plane, and here the body parts, this is the offset of the root. We should select the root also here, and the root, for example, our route has 4 different stop, and with the between these ways we can select how long it should be, or we can even, for example, like change the rotation of the route. Also we can change the camera position, path position. We can change the path position of the camera like this. But if we go here and press this, the auto dolly enabled, it will automatically track this path. So we will choose this one. If you unclick this enabled, then we can change the route, the camera position on the route. But we will select this position and put enabled here. Now let's run the game. Now, as you see here, during this path, it tracked the sphere game object. Now, as a next example, we will implement this feature to this parent and child cube. Now I change the follow and look at property of the Cinemation CM-VCam1 game object to the parent and child game objects here. So it will look at this child game object and it will follow the parent one. So now let's run the game again. It basically follows the parent and child. Now, as you see, it completely follow the route. Like I said before, we can change the feature of this route and the speed of this the tracking speed of this camera, and we can adjust these features for our with our choice.